I'm Father Robert Balacer, the Digital Jesuit, host of TWITE, This Week in Enterprise Tech on the TWIT network. We're here at the Hotstage warehouse, a super secret location in Brisbane, California, for a segment of the Data Closet. This time I gathered a bunch of engineers to assemble one of the most advanced temporary networks in the world, and sitting next to me is engineer extraordinaire from F5, Ken Boccino. Ken, thank you very much for talking to us.
Pleasure.
Your colleague, Sam, came on last week and talked about a denial of service attack, a DOS and a DDoS, or a distributed denial of service attack. One of the key features of any denial of service attack is that it's difficult to tell legitimate traffic apart from, well, attack traffic. That's why it's such a devastating attack on so many networks. You're here today to give us some strategies for mitigating a denial of service attack. So tell me, where does that start?
So you really got to understand that there's different levels of attacks from any DDoS or just DOS attacks. One at the network level to the DNS resolution process to the application level. So we cover all three of those and all the other ones that exist as well. But if we wanted to focus on the application level attacks that you might see as legitimate traffic, let's say a user going to your shopping cart, kind of browsing around, figuring out what they want to buy, then trying to check out. A smart attacker is going to actually work to tear that down and simulate the actual user as if they were a real user. What we're able to do is actually start to look at and create a signature around the type of traffic coming in and basically identify a synthetic transaction from an actual application user. We do that by actually watching and understanding the movements of the synthetic flow, asking the synthetic device to actually answer a few questions for us. Mouse movements, doing some simple math, whether or not they can actually load and deal with JavaScript. And we actually then also watch and look for the flow of the user. So if the user hasn't been to the main website or to a typical entry point for your shopping cart, more likely they're not ready to check out.
If I hear you right, what you're telling me is if you have a sophisticated enough system, you can actually look for what the client is doing. Are they moving from page to page to page to say checkout, as you would expect a regular user to do, or are they hitting the same 10 pages over and over again with no rhyme or reason? And then what's this other part? You actually query the client, so you ask the client to do a little mouse movement or a little math, because obviously an attack computer won't do that, right?
That's correct. So we're actually giving instructions to the user only if they start to look like they're suspicious. So wait a second, you've been to this page a couple thousand times. Let's go ahead and ask you a few questions.
Did you really need to refresh this page so many times?
Yeah, so we can query the user to actually provide some additional information that a lot of the bot networks out there can't do right now.
So whereas with a DOS attack, we could block out an IP and be done with it, if it's a DDoS, what we're really looking for are behaviors.
Yes, we're looking for behaviors, and we're looking to classify them at the application level, at the network level as well. So we can look at the traffic coming in, if it's malformed, if they're doing something at the layer 3, layer 4 packet level, we can actually start blocking and rate limiting that traffic as well.
I want to talk about a different type of denial of service attack that has become popular as of late, and that is a distributed denial of service attack on my DNS servers.
Yes.
That's one of these things that's kind of in vogue. We've known for a long time that DNS servers are kind of the weakest link in the internet, but there's been a general hands-off approach. Don't attack my DNS servers, I won't attack yours. But now it seems like people are using that same DDoS attack against the DNS servers, which can be devastating.
Yes.
And you can't really do the same sort of behavior approach for the application layer, right? I mean, you have to reply to every single DNS query.
Yes, you'll have to answer. If someone's asking for your website, you got to give them your answer. And you can't always rely that source address for that DNS lookup is valid. So it's very easy to spoof a DNS request, and you can't just simply block traffic. So there's a couple different ways we can actually deal with that. Obviously, we want to respond. So if you have a name server that's not necessarily up to snuff with millions and millions of connections per second coming into the infrastructure, we have the ability to actually sit in front of that and protect the zones that you're hosting authoritative for. So we can actually drop traffic out for anything you're not authoritative for. We can filter, so we only allow real requests coming through. And then for the answers you have to give, we can give them extremely fast, millions and millions of connections per second back to the user. But another technology or architecture technique to work with this, and it's being used and deployed and has been deployed in the DNS infrastructure of the web for the last several years, ever since it was built, is the Anycast technology. So the ability to actually have multiple name servers that you're authoritative for live on the exact same IP address across all your data centers, and potentially into some bursting space as you need it, will allow you to actually take on a full-on DDoS attack. People don't think about it, but DNS is the first piece to fail in most enterprises getting DDoS, because you can't answer your name, no one's getting to you.
If I hear you right, it sounds as if you're saying that the way that you mitigate these attacks is, first of all, you have to have a fast box. So you have to have an advanced box that can respond to millions of requests per second, but then also you have to put it at the edge. You have to put it away from your core network so it can respond to those requests without eating up your core bandwidth.
Yeah, so the goal of really our equipment being able to deal with these millions of connections per second is you really don't want those connections to come further into your network, as you say. So putting us at the edge, right at the perimeter, or even up into the cloud, or right at the edge before you get down into your data hosting space, allows you to not have to worry about firewalls infrastructure sitting in front of you and having connection time issues or connection issues. It's really important to put your DNS infrastructure and the DOS protection at the edge as much as possible, so you can deal with the onslaught of open connections per second and block it before it goes into your more session-based network infrastructure, or even your application level servers and infrastructure.
Ken, we're going to have you on again to go a bit more in depth, but until then, where should they go on the web to find out more about what, say, F5 can do to protect against DDoS?
We have plenty of solution articles as well as white papers up on f5.com. And as always, devcentral.com is a great resource to ask questions, to find out what other people are doing against attacks. If you already have the F5 gear, it's a great place to see what rules have been written to deal with things that are happening on the internet and can protect your enterprise against attacks that you guys are currently seeing.
I'm Father Robert, and this has been The Data Closet.